Okay, so let's look at the investment portfolio selection problem. Now, this is a class of problems that are where linear programming is used very extensively. So, investment portfolios, debt planning, long range investment planning, so lots of different things that you can use linear programming for. So, and you can also use some non-linear programming methods. Again, if time permits, during the prescriptive analytics seminar, I will talk about it. Otherwise, we'll go on more examples of linear programming. Okay, so let's look at the problem. The portfolio selection problem involves situations in which financial manager must select a specific set of investments. The objective is usually to maximize the expected return or minimize risk. Those are the two usual objectives that you come across. And the constraints are usually what type of investments are permissible, and maybe your client wants a diversified portfolio and has a lot of constraints based on that. So all of that need to be taken into account. Let's look at an example. So let's say that Wealth Mutual Funds Inc. is located in New York City, is looking for investment opportunities for $100,000. So this is the amount that they want to invest. Now, in these problems, you have two options. You can either go with the amount being invested, and you can say, okay, I'm going to allocate the $100,000 into the different investments that I have. Or the other option is you can say that I'm going to say, you can look at your decisions as the percentage of the total investment that you have that goes into each of these different investments. So I can say that 30% of my investment should be in the first one, 20% in the second one, and 15% in the third one, or something like that. So you can either look at it as percentages or you look at the actual dollar amount that you invest. Either way is okay. Right? Either way is okay. Just that the constraints will look slightly different. That's all. The firm's top financial analysts identified five investment opportunities and projected their annual rates of return. So these are the five investment opportunities. You have Atlantic Oil, Pacific Oil, Midwest Steel, Huber Steel, and government bonds. And these are the expected rates of returns. 7.3% for Atlantic Oil, 10.3% for Pacific, 6.4, 7.5, and 4.5 for Midwest, Huber, and government bonds. Now, one thing, these are expected, projected rates of return. So we are obviously making a leap of faith here, but that's okay. At some point, you have to say, okay, I'm going to invest in Atlantic Oil because I get a 7.3% rate of return. But that is also not straightforward. If you have, for those who have invested and those who are in the financial field, you know that when you look at the brochure for a particular investment, you'll notice that they give you different projections. They give you their 1 year return, their 5 year return, their 10 year return. So these numbers could be any one of them. And it all depends upon what the financial analyst is looking at. Usually, I would say that 1 year returns are not considered. You usually look at 5 or 10 year returns. Let's assume that maybe these are 5 year returns. Right. And these are some of the guidelines that wealth investment has, which is that neither industry, oil or steel, should receive more than $50,000. Amount invested in government bonds should be at least 25% of the steel industry investments. Keep that in mind. Investment in Pacific Oil, the high return but high risk investment, cannot be more than 60% of the total oil industry investment. Basically, you're saying that Pacific Oil, which gives us a lot of return, it's a 10.3% rate of return, but obviously high risk, high return. You cannot have more than 60% of your investment in oil cannot go to Pacific Oil. So obviously what they've done is they've taken these investments and put them into brackets. So government bond is its own bracket. This is the steel industry, and that is the oil industry. And these constraints that you have, these guidelines that you have are based on industries. So how do I go about this? Now you could have used other letters. So let's say you could have say A, P, M, H, and G, and the whole thing would be the same. But here, usually when you have larger number of variables, you usually use X with subscripts. So you have five variables here: the dollars invested in Atlantic Oil, the dollars invested in Pacific Oil, dollars invested in Midwest Steel, and dollars invested in Huber Steel, and finally dollars invested in government bonds. So like I said, these variables could be the dollars invested, or it could be the percent of the total investment that went into Atlantic Oil and so on. Now, the good thing about using the percentage way of doing that is then the 100,000 becomes irrelevant. You could be investing $100,000 or $1 million. All you would do is you would just allocate it based on the percentages. Anyway, let's continue. The objective is to maximize total expected return, and we know the projected return value. So all you're doing is multiplying 7.3% times your investment in Atlantic Oil. So it's 7.3% times investment in Atlantic Oil, 10.3% times investment here in Pacific, 6.4% times Midwest Steel, 7.5% times the dollars invested in Huber Steel, and 4.5% times the dollars invested in government bonds. So these are the expected return values, and you're multiplying that with the dollar amount invested in each of these values. So at the end of the day, all of these five numbers, there's going to be, say, $20,000, $30,000, $15,000, some numbers here, and that's what you have. Now, the first constraint is that you have $100,000 to invest, and the idea is that you will invest all the money. And why would I invest all the money? Why would I not, say, save some of the money? That's because based on the data that you have, the only other option you have is take the money and stuff it in your mattress. And that does not give you any return. It gives you zero return. So that's obviously not going to be the optimal allocation. Putting it into government bond gives you a higher return than stuffing it in your mattress. And that's a decently safe investment. So given that's the case, you're going to say that the total amount invested in all five investments has to add up to equal exactly $100,000. Not less than $100,000, it should be equal to $100,000. Right? That's the first constraint. Let's look at the second constraint. The second constraint says that neither industry, oil or steel, should receive more than 50K. So total amount invested in oil is X1 plus X2 dollars, and total amount invested in steel is X3 plus X4 dollars. So X1 plus X2 cannot exceed 50,000, and X3 plus X4 cannot exceed 50,000. Do you see that? And these are this is a constraint for oil, and this is a constraint for steel. Now let's come to the slightly more exotic constraint. This one says amount invested in government bonds should be at least 25% of the steel industry investments. So the total investment that you have in steel industry. So the amount invested in government bonds should be at least 25%. So at least means it should be 25% of that or more. Now, one of the most common mistakes that I've seen students make here is to assume that you'll be investing $50,000 in steel. We don't know that. All this constraint is saying that it cannot be more than 50,000. The final solution might say, based on the returns, steel can only put $40,000 in steel in total, both the steel investment put together. So you cannot assume that you have $50,000, that $50,000 is the amount that you're investing in steel, right? So given that, we know how much we are investing in steel. We know that X3 plus X4, these two variables represent the amount that you're investing in steel. And you're saying that the amount invested in government bonds should be at least greater than 25% of what you invest in steel. X3 plus X4, Midwest plus Huber. Now, let's look at the final constraint. The final constraint is similar. It says investment in Pacific Oil, the high return investment, cannot be more than 60% of the total oil industry investment. So Pacific cannot be more than 60% of the total. So you say that the amount invested in Pacific cannot be more than, less than or equal to 60% of the total investment in oil, which will be X1 plus X2. Total investment in oil, X1 plus X2. And those are the constraints. X1 plus X2 plus X3 plus X4 plus X5 is 100,000. X1 plus X2 is less than 50. X3 plus X4 is less than 50. X5 is greater than that, and X2 is less than that. And these are your constraints. And this is your full problem. That's the linear programming formulation for this particular problem.